We've spent the last several weeks discussing horizontal motion and some properties of that kind of motion, as well as what do the graphs look for that for that kind of motion, and how do we calculate it. The next thing we're going to look at is free fall motion. The difference between what we've looked at before and what we're going to look at now is before we were moving all along the x-axis. We were all moving horizontally. Now we're going to switch and we're going to move vertically. We're going to move up and down. And so this is going to be the y-axis. Okay. Right. All falling objects will accelerate at the same rate. We're going to call this rate the acceleration due to gravity. We're going to symbolize that with a lowercase g, and the number value for that acceleration is always, on Earth, going to be negative 9.81 meters per second squared. You must memorize this number. Absolutely positively must memorize. You will not be provided this number on quizzes or tests. You must memorize that the acceleration due to gravity is symbolized with a lowercase g and is the number negative 9.81 meters per second squared. Gravity is negative because it pulls things down towards the center of Earth. We said when we first studied our properties of motion that anytime something goes to the left or down, it'll be negative. That means our displacement of falling objects is also negative because they fell down. As we try and calculate free fall motion, we will use the same equations that we used so far for horizontal motion, but only with a few small changes. Anywhere that we had x, we will now have y, because instead of moving horizontally along the x-axis, we're now moving vertically along the y-axis. Also, we will change a into lowercase g, because we don't just have any acceleration, we have a very specific acceleration, which is negative 9.81 meters per second squared. Some problems will tell you gravity, but others expect you to know it. So once again, you must memorize the number and its units. You will not be provided with this number on any quizzes or tests. Okay, let's take a specific look at how these equations are going to change as we go from horizontal motion to free fall motion. For horizontal motion, we had v equals x over t and v equals vf plus vi over 2. Both of these equations can no longer be used because they don't include acceleration. And if something is falling down, it is accelerating. So, these don't have an a, so we can't use them. Okay. Next, we have a equals delta v over t. And we know that a is going to become g. So now we're going to have g equals delta v over delta t. But I'm going to write delta a little bit different just to remind you of what it is. So instead of writing delta v, we're going to put v final minus v initial over t equals gravity. Okay, our second one becomes vf squared equals vi squared plus 2 AY, because we just changed axes. Excuse me, that's going to be GY. Okay, because A becomes gravity. Okay, so again, VF squared equals VI squared plus 2 times gravity times the vertical displacement, or how far did it move, or the height is sometimes what that is called. And then our last equation will become y equals vi times t plus 1/2 gt squared. Okay. If you are provided with an equation chart that only has these equations, you can still solve these problems just by changing the g and the y. We're simply being more specific than we were the first time. So, again, we cannot use the first two equations for free fall motion because they don't include acceleration. And on the bottom, these equations on the right mean the same thing as the ones on the left. We're just being more specific to the situation that we're looking at. We have three main situations for free fall motion, and they're all dependent on what our initial velocity is. We can have an object that's simply dropped, and that gives us an initial velocity of 0. We can have an object that is thrown straight down, and thus has an initial velocity that is negative. This isn't a very common case, though. If we do look at these kind of situations, they will sometimes require using the quadratic formula to solve them. So you may see one occasionally, but it won't be the more common form of situation that we look at. And then our third situation is when we have an object that is thrown up, so it has an initial velocity that is positive. When we look at this kind of situation, we need to keep in mind that the time that it takes to go up is equal to the time that it takes to go down. In some problems, the initial velocity is not stated. However, if we draw a picture, like we're supposed to every time we try and solve a problem, we can figure out what our initial velocity is supposed to be. We can think about, is it going up? Is it going down? If it's going up, it's positive. If it's going down, it's negative. If it's not moving at the beginning, then it's 0. Okay, so I emphasize that you need to draw your pictures to help you identify all of the information given based on what's happening in the situation. Anytime we're looking at free fall motion, at the top of the object's motion, then we have to have a velocity of 0. In some situations, that will be our initial velocity, while in other situations, that will be our final velocity. Again, to determine which is which, we need to draw our picture. Our acceleration will always remain constant at negative 9.81 meters per second squared. Objects that are going up will be slowing down, and objects will speed up as they fall down. So it's a little bit opposite. Okay, if it's slowing down, it's going up. If it's speeding up, it's going down. So remember that those two terms, up and down, are opposite. They can't be the same for these situations. The next thing that you're going to do is you're going to use an app that I have on my iPad called Step 2 Step Mechanics. You're going to work through this app. It's got some sample problems, and you're going to try and solve as a class, some free fall motion questions. Okay. As you do this, if you make a mistake, it'll send you back a step, and you'll just try again and move on. The class that earns the most stars will get a prize.